Clearspan bridges, also called single-span bridges, are a preferred watercourse crossing type, since they can have minimal impact on fish habitat and passage, and can maintain water flow when designed and installed using best management practices. Since these bridges can have all of their components above the high water mark, they can avoid altering the natural stream bed. Key attributes of clearspan bridges include: they have the least impact on fish habitat and passage, less prone to beaver problems, easiest to restore at end of life, and can be built on any gradient. However, they can create traffic bottlenecks and create a higher risk of traffic collisions. Planning is a key aspect to the long-term success of a bridge. Favorable bridge locations include areas with flat approaches, stable soils, and straight channels. Areas with meandering bends and braided watercourses or alluvial fans should be avoided. When designing a bridge, it is important to ensure the proper height and length are accounted for. The height and opening of the bridge should exceed peak flows that occur during flood events, plus an appropriate extra clearance space to account for debris or navigation. Proper bridge length is incredibly important. Bridges need to be long enough that they do not constrict the watercourse channel, and spans should extend beyond the stream banks and the abutment walls. This is an example of a bridge that does not have sufficient clearance and is in danger of blockages. Key considerations: ensure the bridge is long enough for the crossing site with all components placed outside the high water mark. The bridge approach and deck should be higher than the road grade, so any water on the road flows away from the bridge. This redirects any floodwater damage to the road instead of the bridge and helps keep sediment-rich road water away from the watercourse. Bridge surfaces must be enclosed to prevent road gravel from entering the stream. Common methods include wrapping stringers or bottom rails with a geotextile filter fabric or installing kickboards. Water flowing in road ditches should not flow directly into the watercourse. It should be directed away from the road well in advance of the watercourse crossing and diverted into an area with stable vegetation. Do not use leaky machinery or fuel equipment within 100 meters of the watercourse. It's important not to neglect the final details of the job once the watercourse structure is in place. Erosion control and vegetation reestablishment are key to a successful crossing project, as this ensures that the sediment does not impact the health of the watercourse. Best practices: clearspan bridges are often built by dropping the structure over the watercourse. Installation can occur at any time, including winter, when in-stream work is not required. Whenever possible, construct clearspan bridges without entering or altering the stream flow. If in-stream work is unavoidable, construction timing must adhere to the restricted activity period and any regulator instructions. Machinery should be cleaned prior to arriving on site to prevent pollution, the spread of invasive plants, and the spread of aquatic invasive species. Keep machinery out of the watercourse channel and away from riparian areas. Avoid fording. These practices can cause damage to the aquatic ecosystem. Bridges can be set on steel piles, concrete abutments, or properly stabilized native soil. To avoid damage and retain vegetation, any abutments and wing walls need to be placed outside the high water mark and not on the banks of the watercourse. This is an example of a bridge with wing walls improperly placed inside the watercourse. Avoid unnecessary soil disturbance near the watercourse to minimize sedimentation and erosion risk. Existing riparian and upslope vegetation should be preserved as much as possible. This helps to reduce direct impacts to the watercourse and reduce potential for erosion and sedimentation. Additionally, limiting riparian disturbance lessens the amount of revegetation required once the works are complete, which also reduces costs. Erosion protection should be based on Alberta transportation standards and authenticated by a qualified engineer. Wherever possible, establish native vegetation, By doing this, sediment can be trapped and filtered out by the vegetation before entering the watercourse. Only use riprap where it has been specified in the design, and minimize its use elsewhere. Site reclamation. After installation, re-establishing vegetation is a top priority. If high sediment loads enter watercourses, they can have significant negative impacts on fish. All erosion and sediment control measures need to remain functional and on-site until revegetation is adequately controlling erosion and runoff. Reclamation tips. A key step is to place salvaged woody material across disturbed areas to increase roughness, slow runoff, reduce erosion, and prevent access. Spread organics across the site to promote natural species regeneration from seed banks. Supplement with seeding or transplanting. This again helps establish vegetation that can aid in controlling sedimentation. Protect exposed soil and reclamation sites from rain erosion. Biodegradable sediment control options are the best, as they do not need to be removed. Monitoring and follow-up. Over time, excessive road material can be dragged onto the bridge. Several methods can be used to prevent this material from entering the watercourse. Install kickboards, also called curtains, gravel guards, aprons, or bumpers, along the edge of the bridge rails. As you can see, this site has exposed soil and bank erosion. Erosion control and establishment of ground cover is required to prevent sediment from entering the watercourse. Investigate how the road is being graded and ensure road approaches are being graded away from the bridge. This helps direct any sediments away from the watercourse. When Clearspan bridges are designed and installed with peak water flows and fish health in mind, these types of structures can be very effective at ensuring that minimal disturbance is created during installation and over the lifespan of the watercourse crossing. It is key to monitor your Clearspan bridge to ensure that it is continuing to work as intended and that erosion, sedimentation, and blockages are not occurring.